like to go back to tangents by building what tangent is meant in terms of x's and y's. When we talked about tangent in the ordered pairs, tangent is what over what?
Y over X.
Very good. Y over x. So when I'm looking at a tangent, I want to look at it off of the unit circle again. And the easiest parts of the unit circle to work with are always to start with your quadrantals. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Everybody agree on that? There's another angle that tangent was always nice to work with. What was the really nice angle of tangent? 45 degrees. Correct, because the tangent of 45, or the tangent of pi over 2 was always 1. 1. Because it was root 2 and root 2 over 2 and root 2 over 2 for the cosines and sines. So at 45 degrees, we always, at pi over 4, the tangent was always equal to 1. Here it was equal to negative 1, positive 1, and negative 1. Everybody agree on that?
Yes, sir.
So as I'm going around the circle, I have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Everybody agree with that?
Yep.
Yeah. So here's what I'm going to do. I'm going to keep that generic quadrantal-ish looking thing on the right, but I'm going to plot an XY grid of tangent here. And I'm going to start going at 0. When I start at 0, what's the tangent of 0? What's y over x at 0? It's 0. Y over x when you're at 0 is 0 divided by 1. You get 0. At pi over 4, what's tangent always equal to? 1. What happens at pi over 2? What's tangent at pi over 2? What is, it's undefined. When you have an undefined value in your graphing, how do you represent that? A vertical asymptote. Remember, when you have a vertical asymptote, that's when you have a 0 in your denominator. So at pi over 2, you have a vertical asymptote. Everybody agree with that? Let's go the other direction. If I go this direction, that's negative pi over 4. Do you agree?
Yeah.
At negative pi over 4, what was the value of tangent? It's negative 1. If I come down again to negative pi over 2, what was the tangent at negative pi over 2? It's also undefined. So at negative pi over 2, you have another vertical asymptote.
So
Can, yeah, because can that curve get outside the asymptote? It's going to get infinitely closer and closer and closer to it, but it's never going to jump the asymptote. So what happens here is you get this curve that's increasing. It's increasing from negative infinity to positive infinity, going from left to right. Now, this happens every pi within the graph. If you notice, the distance between negative pi over 2 and pi over 2 is how much? What's the period then? Pi. Tangent's period is different. It has that jump when it gets to pi over 2's. No matter what revolution of pi over 2 you wind up at, you're always going to be at a vertical asymptote. Whether it's at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on and so forth. It's going to oscillate to that asymptote each time. That's why we have these vertical asymptotes. One of the other things you'll notice with tangents is that there's really only 3 points that you're plotting. The origin, the halfway between the origin and an asymptote, on both sides. Tangent is very easy to graph, but what's going to be weird is working with those fractional amounts on the interior. Okay? So let's write out the generic form, do a generic graph, a parent function. Then we'll plot a shifted one and call it a day. Sound good?
Yes.
All right.
What do you say? Call it a day and
Y equals A tangent B of X. Now,
at least he didn't drop his calculator.
no, you already
I
did
don't
it.
have my
It's already
calculator.
broke.
Oh, it broke?
Yeah.
Yep.
So let's take a look at this. When we have A times tangent B of X, this value of A is no longer the amplitude because there's no maximum value for tangent in its graph. Since it's always increasing or always decreasing on either side, there's no maximum or minimum value. This A value yeah, this is the A value. This is the A value here and here now. Okay? That A value are those points on the y-axis. Now, if A is negative, is it going up and right or down and left?
Down and left.
Exactly. Just like we did yesterday and the day before, if you had a negative A value for sine or cosine, sine instead of going up first, it would go down. Cosine, instead of starting up top, it would start at the bottom. If tangent has a negative A value, instead of increasing, it's decreasing. That's the only difference. The B value allows us to find the period. The period for tangent is always pi divided by the absolute value of B. To be honest with you, I don't think we will ever have a negative value of B. I don't think this book even has any. It's not that big of a deal because you're taking the absolute value. And then the other part that comes up with the tangent graphs deals with the asymptotes. And if you go back and you think about the first one that we did, remember how we talked about the period of the original tangent was pi? That split it up. This whole distance was pi. The origin was halfway in between it, which meant how much was on both sides? Half of it. So one half of the graph lied on one side of the origin, the other half was on the other side. So the asymptotes are going to occur at pi over 2 multiples. It's easier to do this visually than it is algebraically when I show you the example. They occurred on these odd multiples. It's much, much easier to show it with an example than it is just with the simple formula. You'll be able to pick up on it real fast.
I love just a recommendation for my hand. I don't worry about it. Thought maybe I left them on your desk when I ran out, but no.
I don't think you had anything in your hand you wanted.
Yeah, I don't know. Security might have it when I was messing with the locker. Either that or you guys are having some fun. Either way, I can print it out.
No, I didn't.
Because that's
Normally-
something like that guy right there would do.
No, that's what we, that's what we would do. But
I know.
That's something I would do.
No, say that about me.
I know. Yeah. I've known him forever. It's okay.
Not forever.
Oh.
Yeah, did you know him since ever?
Let's try this. Now, again, like we did yesterday and the day before, whenever we have sine and cosine, whatever the trig graphs are, we're always going to do the same scenarios. Label everything first. It just makes your life so much easier.
I don't know if I get where
We're graphing.
we're going. Like this tangent. It's so different.
It's actually, believe it or not, it's very easy.
I don't like change.
What's my A value?
3/2.
3/2. And what's my B value? 4. So my A value is 3/2. My B value is 4. That means what is my period?
Pi over 4.
Pi over 4. Remember, the period for tangent is always found by pi divided by the absolute value of B.
Oh, you that's the answer. Yeah.
One trick that I'll tell you guys when you're graphing tangents, make your grid a little bit wider than what you think you need to. It'll give you a little bit more space, especially when you do your shifting, because there's a lot of stuff, a lot of asymptotes and things like that that will show up.
So it's a bit, when you shift, you have something to shift also.
Exactly.
It's like a sideways T.
All right, so there's no h and there's no k in this problem, which means that no matter what, it's always going to go through the origin. Okay? The parent functions will always go through the origin. Okay? When you start the graph here, you know one set of ordered pairs will always be 0, 0. If I know that my period is pi over 4, that means I have an asymptote on both sides of the origin, and the total distance between is pi over 4. Again, that means half of it is on one side, and the other half is on the other. So what is half of pi over 4?
Pi over 8.
Very good. Does that make sense how I did that just verbally as opposed to substituting into the formula?
I think the substitution was pretty easy. Wait, you said that means we're gonna. Why does pi over 4 mean that there's gonna be 2? Is there always 2 or?
What do you mean by there's always 2? You mean
I
by
think
the
I think you said our period. Maybe just how you said it. Like I took this a little, but you said since the period is pi over 4, we're gonna have asymptotes on both sides.
Yes, what happens is with every single parent function of tangent, it's always going to go through the origin. So that means that half of the graph will be to the right of the origin, the other half of the graph will be on the left of the origin. Therefore, you'll have 2 asymptotes.
Every time.
Every time.
Okay.
Yes, sir.
If the a value is negative, does it go from positive infinity to negative?
Correct. Yep. And my next example is that. Yes, ma'am.
Why do we have an asymptote that's
This is an eighth, correct? This is an eighth, right?
Oh, one.
See that now? And that's where it gets a little bit weird when you start to think about it's fractional on both sides, but when you put them together, it is that whole fraction. Okay? And that's why I always say tangent's a little bit weird as far as everything else is concerned. So we've got our origin, we've got our asymptotes. The last pieces to put in are the halfway points between 0 and that, and 0 and that. So what's halfway between 0 and an eighth?
Pi over 16.
Very good. And then here will be negative. A in this case, is it positive or negative?
Positive.
It's positive. It's positive 3 over 2, which is 1.5. Everybody agree? So here's 1, here's 2, so here's 1.5. Here's 1, here's 2, here's negative 3 halves. Again, A is positive, it's increasing going from left to right. It just matches up.
So your A is just your y value.
Yep. That A value will be the y coordinate for the halfway points between 0 and your asymptote each and every single time. Every time. And if A is positive, it's increasing from left to right. If A is negative, it's decreasing from left to right. Not scary?
So your coordinates negative pi over 16 comma 3, negative 3 over 2.
Yes, sir. So your coordinates in this case would be negative pi over 16, comma, negative 3 halves, 0, 0, positive pi over 16, and 3 halves.
Sweet. I like it.
Told you it wasn't bad.
We get our
Let's do a shift real quick, and then we'll call it a day.
No.
All right.
Fair enough.
I'll put in a K.
We're losing the final 4.
So y equals negative 2 tangent times the quantity x plus pi over 4 minus 2. Now I have an h and a k. I treat the h's and the k's identically like I did with sines and cosines. The only thing that's different here is that when I plot these things out, I'm going to plot out my my asymptotes, my parent graph, the same way as I would, but I have to shift everything, which means I think someone already asked, do you have to move your asymptotes? Yes. Now, when you move your asymptotes, do you have to worry about moving them horizontally, or vertically, or both?
Horizontal.
only have to worry about moving those asymptotes horizontally, because if you move a vertical asymptote vertically, it's still there, isn't it?
Yeah.
There's no getting rid of it. It responds.
So, just like we've done before, what do you think my first step is going to be? List out. What's A? B?
1.
H?
8.
Negative.
Very good. And K. So does everybody agree that this graph is going to have to shift left and down?
I bet.
What is my period for this being a tangent? Good. Remember, period for tangent is always going to be pi over b, or absolute value of b, excuse me, and go from there. Again, we know that's going to have to get shifted left and downward. I might play around with how I draw my original graph just to kind of give myself a little bit extra space. Just see how I might have moved it over just a little bit. It doesn't really matter. I will recommend try to use a little bit more space for tangent than you think, just because it's easier to put your fractions in. All right, yes, sir. Period is always pi over b, absolute value of b per k.
Is it 2 pi?
That's the
Oh,
answer.
I didn't know this was held.
Wait. But for cosine and sine, it's 2 pi.
Right. Because cosine and sine, there's no asymptotes.
Did you hear that?
Yeah, so it's just going to be pi over b, and b is 1, so it's just pi. Again, since my period is at pi, my parent graph always goes through 0, 0. Where are my two asymptotes going to be located? Pi over 2 and negative pi over 2. Oops.
Because there's b.
What's the halfway point between 0 and pi over 2? Halfway point between 0 and negative pi
Negative
over
pi
2.
4.
I know my a value is negative 2.
Does the sign of the a matter at all?
It does, it just
Oh,
goes in
okay.
direction.
Fair enough.
Since my a value is negative with this tangent graph, is it going up and right or down and left? Or down and right, excuse me.
Down.
Right.
Which is
Down.
Right, down right.
down right. So at negative pi over 4, it'll be at positive 2, 0, negative 2.
Oh, yeah, got it.
There is my parent graph. Now, shifting tangents is actually really easy. Label, we have negative pi over 4, 2, 0, 0, pi over 4, negative 2. My h and k in this case was negative pi over 4 and negative 2. Which one of those three ordered pairs is going to be easiest to shift first?
Probably the 2.
0, 0.
The 0, 0.
Oh, the 0, 0. I thought.
Now, again, the reason why I'm going to start shifting my origin is because adding and subtracting to 0 is the easiest way to go. So I know this is going to become negative pi over 4, negative 2. Now I have to go to the other ones. Well, what's pi over 4 minus pi over 4? 0. What's negative 2 minus 2? Negative 4. What's negative pi over 4 minus pi over 4?
Half negative 5.
Very good.
Yeah.
And then 2 minus 2. 0.
Settle.
Now the tricky part,
Ooh, that.
the asymptotes.
Asymptote. That's not tricky.
I have an asymptote at pi over 2. If I have to move that to the left, pi over 4, where does it go?
3 pi 4.
3 pi over 4 would be going to the right. That'd be going all the way
Pi
down
over
here.
8.
Wait.
Pi over 8.
If you have a quarter, if you have 50 cents and I take a quarter, how much is left? So where does pi over 2 go? Pi over 4.
Oh, my.
What we're doing here is we're taking the asymptote of pi over 2 and I'm subtracting pi over 4.
Oh, you're talking about the right one? I was doing the other.
Oh, we do that? I'm sorry. I'm
I
sorry.
was doing the y.
Yes, you were right. I didn't hear you say negative. That's
Oh,
why.
that's all right.
That's why. Yes, you were right. You did it. Yeah. So if I take this one and I go from pi over 2 to subtract pi over 4, I go to,
Pi over 4.
it goes to pi over 4. So there's now an asymptote here at pi over 4.
How do we signify like which ones?
Make stars.
Maybe write down their new asymptote. Make new asymptote.
How about
Sorry,
bigger
just
boulder
made it more-
dashes?
Boulder dashes.
Yeah.
Sort of
Maybe
boulder.
you can make a straight line, no dashes.
I'd like to.
Darn it, I accidentally flipped my line.
And then the other one, like Morgan said, is at negative 3 pi over 4. Or if you have two different colors, that would work.
On the quiz, how you?
The quiz is very specific. Just like I've been saying, list out your ordered pairs. It'll say new asymptote. It'll say what is the new asymptote, where is it, that kind of thing. So it's very, very specific. Again, I know that my ordered pairs. Let's see. I have to go to a negative 4 at 0, negative 4 at pi over 4, negative 2. And then negative pi over 2 and 0. Now, with my shifted graph, is it okay that it lands on the old asymptote, the parent
Yes.
function asymptote?
That's not real anymore.
Fine. You're right. It's not real anymore.
Now there you
And neither was the replicate.
And that's how you shift the tangent.
You run the streets these days.
I'll try not to. Is it June?
Oh my goodness, Murph. So original. You're so origin. You are so XY, Murph. Good math joke. A good math joke is he was like Walter White.
Anyway, questions? Pay close attention when they throw a B value in here on you. They will do it. Okay. Same page for homework. It's on page 845. I think it's 43 to 49 are the 6 I want you to do. I believe that is the right number.
every other lap.
44, sorry, it starts on number 44. All right, we'll go ahead and get those. We'll go over this stuff tomorrow. I'm gonna try and get a couple of trickier ones on you, just to mess with you. And we'll quiz out of this stuff on Friday. Friday the quiz is just 4 questions. It's 4 graphs. Okay, just so you know there'll be 4 graphs. It is non-calculator.
How
Is it
long
on a
do you
pink sheet?
How long do you think it would take?
The graphs
Yeah.
should take more than a half hour. I mean, because it's very specific, because I want all the specific ordered pairs and all that stuff written out. So,
Why didn't you?
I don't know. I don't know. I don't remember. Yeah. No, I made it. There are 6 different versions of this one. Come on, get started, please.